In this video, I'm going to show you a truly remarkable book that stands out as one of the simplest, most complete, and beginner-friendly guides to general theory of relativity. It teaches you everything from the essential mathematics to the deepest concepts of space-time, black holes, cosmology, all explained step by step in a way that anyone can understand. My name is Shaunak and you're watching this video on my channel Physics for Students. Now before I go ahead and tell you about this magical book, I would like to address this question: what kind of mathematics you need to know before you start learning general theory of relativity? Well, in general, obviously it comes as a common notion that general relativity is a very complicated subject. Well, I would partially accept and agree to that, because the mathematics that describes force in Newtonian mechanics, F equals to ma or others, that mathematics now describes what is called gravity as a space-time curvature. So no longer the particles, the distance, but something purely geometric in nature, some amount of complex mathematics. The straight line or the Euclidean metric now becomes far more complicated, and it looks monstrous equation like this, which is called a geodesic equation. Also, the Einstein field equation, as you know, it contains a lot of tensor components and stress energy momentum tensor, etc., and the very big and the complicated Riemann curvature tensor. All this actually brings us to the conclusion that in general GR is a theory packed with lot of complicated math, lot of intricate equations, and an idea which seems to be very difficult, eluding, and difficult and hard to grasp. Now, so from here, what we can understand that is not entirely true, because if you go deep in understanding Einstein's field equations on general relativity, it seems that it is extremely simple, and the fact is it is that, and it is very deeply intuitive. Now, all these equations actually describes how gravity works. It works not as a force but as a space-time that bends matter around, and what we can see, the things going around a solar system, the planets, all those things, these happens not due to any force but the bending of space-time, and that makes the theory even more beautiful and even more elegant, understanding gravity at its core. But one question that comes to our mind is that what about the mathematics? It seems to be truly difficult, truly complicated, but I would say that it is just a precise language. Mathematics in general is also a language. It helps us to describe this intuitive picture of gravity, curvature, etc. in a consistent way. It also allows you to make accurate predictions and perform calculations and communicate all those complex, intricate, complex ideas without ambiguity. Now, when we talk of mathematics and tell that it is not entirely true, I have already made a series of videos last year. Part 1 talks about the calculus and partial differential equations, so you can understand why Einstein field equations are required and partial differential equations are required to understand that. Then there is a second video which is talking about linear algebra, which is a kind of a precursor to tensors, matrices, etc. Then on the third video I have talked about tensor calculus, not only why tensors are required, a little bit of history, what are the books, most importantly, what are the resources. So part 1, part 2, part 3 all are related to how to learn, what concepts you need to know, not all the concepts of calculus but some of them, which part of linear algebra is particularly important, what book you will read, and so on. Then in the fourth video I have talked about differential geometry, which is we can tell the heart of general theory of relativity, manifolds, what books to read, what are the concepts that are very important. And the fifth part talks about what is called the non-Euclidean geometry, the spherical, the hyperbolic, all those geometry which are non-Euclidean in nature, why we need to understand, what are the books and resources. So all these, as you can see, are on my playlist How to Learn General Relativity, and it is there on my channel Physics for Students. If you are really willing to learn the core of the mathematics, which books to read, how to approach, which part of the mathematics is relevant to GR, please go ahead and watch those videos on my playlist General Relativity, which is on my channel Physics for Students. Now, when we are going to learn about this magical book, I would like to give you a kind of a checklist, a kind of a check factor that what are the key factors you need to understand when choosing general relativity. A book on general relativity. Now, over my years of teaching experience, and at least I have made more than 20 plus reviews on different books of general theory of relativity, some of them fairly intuitive, some of them complex, some of them both are kind of a balance between intuitive and mathematical concept. There are many books which are available, and this choice actually confuses students and people who are going to learn GR. So every choice opens up a door but also closes countless others, and with each decision it comes with a responsibility of knowing what you leave behind. And when I talk of this choice, it reminds me of the same famous film Matrix, where Morpheus was actually telling to Neo that you take the blue pill, the story ends, you wake up in your bed and believe whatever you want to believe. You take the red pill, you stay in Wonderland, and I show you how deep the rabbit hole goes. So obviously we are not taking the blue pill, we are taking the red pill in this video, and I'm going to show you how deep the rabbit hole actually goes. So choice is a very important factor. So I would like to tell you that these are the things which you should keep in mind. Do not select a book that has the following factors. A book that has a lot of confusion due to excessive abstraction too early, do not go for this book. Do not go for a book that do not have a lot of examples. There should be a lot of examples. So lack of clarity and examples is another. Do not go for a book that has skipped explanations and prerequisites, because explanations and prerequisites are important. Do not go for a book that has mismatched learning goals. That means your goal is to get a fairly intuitive idea, you are going for a mathematical book, or vice versa. Do not go for a book which is very formal or explains something subject like GR without a hint of mathematics. Do not go for a book which is outdated, because there are certain mathematical notation and styles of writing which changes with the passage of time. So check out with the version, etc. Do not go for a book which is poorly organized, that creates a confusion. Also, do not go for a book where there are too few exercises or no solutions provided, because exercises do help and make your learning more profound. So as I told you, what Morpheus told to Neo, that which book you select or which choice you make, choosing a wrong book can actually waste a lot of time of yours. You find at the end a lot of frustration creeping in your mind, and you find that general relativity is not the cup of tea for you. So what are the things that you should do? I would say what Morpheus would advise to Neo. So first thing is that the level of rigor. So try to find out what level of mathematics you know, or what is your objective. So if you're new to GR, then start with a book that emphasizes more on the physics part, intuition, step by step, etc. Also, you should check out a book that balances between concepts and computation. Some books are too rigorous, only doing the mathematics. There should also be the presence of concepts. Mathematical prerequisites, the book that we will talk about, you will see, you will feel surprised that how can this type of a book can be written. So there should be a proper mathematical prerequisites clearly mentioned by the author during the preface or the introduction part. Level of abstraction, from beginner you can prefer example based low abstraction books, and further you go into higher abstraction for advanced learners. Also, I would say that check out where there are a lot of problems, because maths and physics, something these are more developed through exercises. The style of presentation, sometimes author's style of presentation is not up to the mark. So we can summarize that you need to check the reviews from other learners. Also complement your textbook with some online resources, lectures, etc. That makes the book self-complete. So these are the factors that you should select, and earlier I have explained that be aware that these are the factors you should consider, and you should avoid those things which I have just told you. So now we come to the magical book which is written by Peter Collier, and the name of the book is The Most Incomprehensible Thing. I think the author has actually done a justice, because a most incomprehensible thing, this reminds me of Einstein's famous quotation, the most incomprehensible thing about the universe is that it is comprehensible. This is from a letter of Physics and Reality 1936, and once we complete the video you will understand that Peter Collier has done a proper justice, because at the end of this book he has made the most incomprehensible thing comprehensible. So I would say this is a crowning jewel in the collection of book. You will soon understand why. It is deeply insightful and remarkable. Peter Collier's work is nothing short of a masterpiece. As I would again repeat, he has actually justified that making an incomprehensible subject GR to be comprehensible. So here you can see these are few of the reviews that I have taken. All of them are writing book is astonishing, but book lives up to its name. Well, it lives up to its name. Much of this is provided incomprehensible to me. I had been looking for books that would give a mathematical introduction to special generals. So overall you can see that all the those who have made the review have agreed that this is really a wonderful book. Before I go ahead and make you understand about the content, the details of the book, first of all I would like to tell you how the book is arranged, because this is pretty important. Now the first thing is that the book first starts with building up your mathematical foundation in terms of GR. So this is just a glimpse. We will go now in the table of contents. So it starts first with functions, trigonometry, calculus, matrices, vectors and so on. So first the mathematics part is dealt with. Obviously the second part, Professor Collier deals with what is called the Newtonian mechanics. So all the laws of mechanics, gravitation, gravitational potential energy, all of them are being covered. So you can understand how beautifully, chronologically, step by step things are building up. So obviously from Newtonian mechanics we move in what? The special theory of relativity, which is relativistic physics in its first part, space-time events, Lorentz transformation, Minkowski metric, every single thing is being covered in beautiful details. Then comes part 4, which is differential geometry. As I told you, differential geometry is important. So the author teaches you about manifolds, tensors, geodesics, Riemann curvature tensor, Ricci tensor, and a lot of other things. So you start with the foundation, go to the classical part, then you move to the special relativity, go to the geometry part, which is the differential geometry, and then the author moves in general relativity, principles of equivalence, geodesics, dust, perfect fluid, Einstein field equations, and a lot. Then he proceeds to make you understand about the Newtonian limit. That means how the first law, second law changed with Einstein field equation, the Poisson equation, and so on. Then comes the Schwarzschild metric, where the Ricci tensor components, gravitational deflection of light is being covered. Then comes Schwarzschild black holes. How will you feel? And the mathematics regarding falling into a black hole, falling seen up close, falling seen from far away, coordinates, light cones, and so on. Then comes the part 9, which is the cosmology, where the author describes about Hubble's law, Robertson-Walker metric, the de Sitter model, and so on, and finally ends with a bibliography appendix and a note of acknowledgement. I think that right now you can understand how beautifully well arranged, scientific, and a self-complete step-by-step this book is. It requires nothing, absolutely zero knowledge of mathematics and physics, and you can start learning from this. So I would say another important part of this video is that each concept of the book is accompanied by an exercise. For example, if you're learning connection coefficients, you will get a problem like this. Calculate the connection coefficients of the Christoffel symbols, etc. So that is a good part. If each of the concept that you learn or immediately you do an exercise, the foundation becomes much more clearer. Second, for example, covariant differentiation. This is an important and vast concept. This also have another problem. For example, find the covariant derivatives of the tensor this and this, and it gives the solution also. If you are unable to solve, you can flip over the pages and you can find this book to be truly great. For example, proper time and time dilation. Again, there's an exercise which is a very common, the muon lives. This is a common exercise which is found in BSc and other math book. Tensors, again, you get an exercise. So overall, I can say that the arrangement of the book is not only chronologically, scientifically well arranged, but each and every concept is accompanied by an exercise, which makes the understanding far more profound. Now it is the time that we go deep into understanding what are the table of contents. So first it starts with the title page, copyright, dedication, and then it goes in the foundation of mathematics. I have not put down the page numbers, but it is around 500 pages book. But the author truly spends a lot of time, as you can see from this list, about foundation and mathematics. It starts with simple things like units and constants. Can you imagine? Then it goes in graph and simple functions. Then the radians, trigonometry, the school days arithmetic. Then it goes in coordinate system. Then the calculus, differential, integral, Taylor series, parametric equations, matrices, introducing vectors, Euclidean metric, and the index notation. So a fair amount of time has been spent by the author in developing the foundation. Why? Because this would be required in further understanding the physics of general relativity. Here you can see then it starts with Newtonian mechanics, very detailed, all the three laws, and then gravitational acceleration, tidal forces, etc. Then it moves a part 3 in special theory of relativity. Everything, space-time events, frames of reference, Lorentz transformation, Minkowski metric, four velocity, relativistic momentum. Well, will take a lot of time. If I go each and every, you can pause this video and take a note that how intense and deeply the author has covered. It then starts with the differential geometry, introducing manifold. Then it goes deep in scalars, vectors, and one form and tensors. Covariant, contravariant, everything is covered, and more on curvature, because curvature is the key of general relativity. So the author covers parallel transport of vectors, Riemann curvature tensor, Ricci scalar, and so on. Not only that, the author further describes this part, which is the core part, that is general relativity. Now you see, before coming to point number 7, there has been so many pages which is covered with the mathematics and other part. And I think that is true, because before coming to this, there is a lot of things and a lot of homework needs to be done. So from part 7, the actual physics of relativity starts, GR starts. So in space, time, dust, perfect fluid, and then it explains the Newtonian limit. That means what are the limitations and how things got modified up till Poisson equation. And then it deals deep in Schwarzschild metric, Ricci tensor components, proper distance, geodesics, perihelion advance, the first, second, and the third tests of general relativity, and so on. And then it goes in Schwarzschild black holes, relationship, gravitational redshift, luminosity, and others. And then you can see it ends with cosmology, where you find all the Friedman equations, the static Einstein model, the de Sitter model, Einstein de Sitter model, and finally with the bibliography, appendix, and acknowledgements. So it's a huge, deep coverage, step by step, taking or hand holding you from the mathematics to the physics and everything. I am truly blown away when I read this book. So the book also contains, as you can see, a lot of pictures, illustrations, but I won't say that illustrations are very extraordinary, but yes, whatever is required. So divergence of the vector field, parallel transport, Schwarzschild metric. The first one is basically the partial differential equations where the curves x and y both are varying. So more or less you won't be, I won't say that it is great in terms of drawing the pictures, but what is required, that is being covered. So now I will come and I will give you an honest review of the book. So what I would tell, it first builds the foundation on mathematics, then you need to learn Newtonian mechanics, move to special relativity, differential geometry, then go to general relativity, then understand the Newtonian limit, Schwarzschild metric, black holes, cosmology, and so on. What I can tell you also is that this book is not only truly a gem of a collection in your library for general relativity, but in case you are a teacher or you're developing a course or a curriculum in general relativity, this book is going to help you. Why? Because it is a perfect chronology. When you're designing a curriculum, you should do like this. You build up a student's math part, then you go to the classical part, then you go to special relativity, then you teach the geometry, then go to general relativity, then understand the Newtonian limit, and end with cosmology and black holes. So left hand side you can see it is written, a self-study guide to special and general relativity with numerous fully solved problems. So I think this is I really have no words about this book. This is truly a great book to start for anyone who is interested in general relativity. So the review is that it assumes no prior knowledge. So it starts even, I would say, with a equation of 1 plus 1 equals to 2. It has a very comprehensive mathematical foundation. It is done in a very chronological way, not in a haphazard way. So you slowly develop the concepts and then go in GR. There are a lot of detailed explanations, and there is a balance between theory and application. Lot of exercises. Each and every concept is accompanied by exercise. Perfect coverage of differential geometry in terms of GR, and it is an excellent treatment of Schwarzschild black holes and well structured and chronologically coherent. So this is my honest review of the book. I have read it numerous times, have referred to in many lectures and notes. I think this is a highly recommended book for self-study. You just have to be curious, pick up the book and start reading. So another important part which came to me, that when I went to the bibliography section of this book, that means this part, these are the things which the author has referred. Few books came in picture. First one, the classic Space-Time and Geometry by Sean M. Carroll. The author has referred to this book. The very classic Bernard Schutz, a first course in general relativity, and by the same author, Gravity from the Ground Up. So he has referred, and he has referred to our good old great professor, Professor Leonard Susskind's series of GR lectures at the Stanford University. That means that if you want to take a leap ahead from this very book to a little bit more detailed understanding, you can either start with Carroll's book or go to Schutz's book, or if you're an online learner, you can start understanding the lectures and listening to the lectures of Professor Leonard Susskind. So this is a quick time that I should summarize. So what we have learned is that in order to select any book, go through the checklist. In short, this book, I would say it is a wonder, really. All you need is a passion to learn. Pick up this book and general relativity will just be a kind of a cakewalk in front of you. You can brush up with concepts like calculus, matrices and vectors. Please do all the exercises, do not skip on any topic, and for further references a little bit more deeper, you can go to Space-Time Geometry by Sean Carroll or Bernard Schutz's famous classical book, A First Course in General Relativity. So all about it again is the choice that we made. So I would try to quote this part. Curiosity is the spark that illuminates the path of knowledge. In the vast universe of space-time and gravity, every question you ask brings you one step closer to understanding the incomprehensible. And by the end of this book, you will make the incomprehensible very comprehensible. Well, that's all for today's video. Thank you very much for watching. If you have liked this video, please click on the subscribe button to subscribe to my channel Physics for Students, and click this bell icon so that you get all the notification from this channel. You can follow me on my other social media handles, and you can write to me at this email ID. Stay tuned for yet another podcast coming up by the end of this month, and we will see you soon in the next video. But till then, may the good Lord be with you.